All right, picture this. You're deep in the zone, building an amazing new feature. Your code's clean, tests pass locally. You push your changes, excited for feedback, but then...
Or frustration.
Hits, right.
Yeah.
You need to check those changes out in isolation, get quick feedback, maybe share a live demo, and all without breaking a shared environment, or maybe worse, just burning through the cloud budget. Sound familiar?
Oh, absolutely. It's a classic problem in software development.
And for many, this elegant solution has emerged. Ephemeral environments, like temporary disposable sandboxes for your code. Great idea, right?
Yep.
For testing, reviews, collaboration.
Fantastic concept.
But here's the rub, the catch. The most common way teams do this, they provision everything from scratch for every change. We're talking a whole new VPC, its own database, a fresh load balancer, all the microservices, just for one PR.
Exactly. And while that full infrastructure deployment gives you perfect isolation, which sounds great, it often comes with these, well, significant hidden costs, especially if you have a large setup, lots of microservices. You're looking at potentially enormous bills. And plus really slow feedback loops, because provisioning takes ages, and then there's the whole operational headache of managing and cleaning it all up.
Yeah, the cleanup.
For many teams, it's not just like a small challenge. It can be a deal breaker. Makes the whole ephemeral environment dream kind of unaffordable.
That's a really powerful point, and it sets us up perfectly for today's deep dive. We're looking at Rewa, a company that hit this exact wall. They loved the idea of ephemeral environments, that isolation, that speed, but the cost of duplicating everything just wasn't sustainable.
Right.
So they asked, okay, how can we keep the benefits but ditch the crazy costs? And that's our mission today. We're diving deep into Rewa's really ingenious approach. Cost-effective, selective deployment. We'll break down how they built it, the architecture, the developer experience, which sounds amazing, its impact, and crucially, lessons for you.
Sounds great.
So let's start by really drilling down into that common but costly problem. Full infrastructure deployment. Just to recap, you open a PR and boom, the entire application stack gets duplicated. VPC, database, queues, every single microservice, just for your small change.
Yeah, and like we said, the big plus is total isolation.
Right.
Minimal risk of things interfering, But for Rewa, that approach just wasn't going to fly. It was, as you said, incredibly expensive. Took hours sometimes to provision.
Wow.
And the operational load just became too much at their scale. The burden just outweighed the benefits, really.
Absolutely. If you've got, say, dozens of microservices, duplicating the whole thing for every little PR, it adds up fast. Massive cost.
Running all those idle resources.
Yeah.
Just waiting for a review. Your cloud bill just climbs and climbs.
So, okay, full duplication was out. How did Rewa innovate here? What was their breakthrough?
Their core idea is selective deployment. It's more than just a small change. It's a different way of thinking. The insight is basically you don't need to rebuild the whole universe for every tiny code tweak.
Right. By cleverly reusing what you already have, the existing clusters, VPC, database, default services, and only spinning up the specific services that actually changed in that PR. Well, that's how they slashed costs and sped things up.
Sounds brilliant, yeah. Very efficient.
It really is. Simple idea, but powerful execution.
Okay, but reusing infrastructure, that immediately makes me think, how did they handle things like data isolation or making sure requests go to the right version of a service? That seems tricky.
Yeah, that's where the clever mechanics kick in. So first, you've got your shared baseline, all the core stuff, services, databases, queues, they're just running normally in shared clusters.
Okay, standard setup.
Then, the PR-specific part. A PR modifies, say, Service A. Okay, only a new container for Service A gets launched, nothing else.
Just the one container.
Just the one. But the real magic is the dynamic routing. The load balancer gets rules added dynamically. So requests coming into a unique PR subdomain, like pr1.yourapp.com, they get routed straight to that new PR-specific container for Service A. Ah, okay. The load balancer is the traffic cop.
Exactly. And here's the other key bit. The fallback mechanism.
Oh, yeah.
If a request comes to that PR subdomain for a service that wasn't changed in the PR, say Service B, the load balancer just routes it to the normal shared default version of Service B.
Oh, I see. So the PR environment doesn't need the whole stack. It just uses the shared ones for anything unchanged.
Precisely. It only deploys and routes to the pieces that actually changed.
That dynamic routing. That sounds like the real game changer. It makes it feel isolated. Can you walk us through an example? Like, what does a developer actually see?
Sure. So You make a PR, it gets a URL, let's say https://pr1.example.com.
Okay.
Now, if you hit service 1 on that URL and you change service 1 in your PR,
Yep.
the load balancer sends that request straight to your new PR-specific service 1 container.
Got it. My version.
Right. But here's the cool part. If you then hit service 2 on that same URL, https://pr1.example.com, and you didn't touch service 2, it just falls back. The request goes to the shared default service 2.
Oh, okay. So it works seamlessly. Looks
Yeah.
like a full environment, but it's mostly shared.
Exactly. You get that integrated experience, feels like its own dedicated environment, but without that massive duplication cost. It's really elegant.
Incredibly elegant.
Yeah.
Best of both worlds, it sounds like. Okay, let's dig into the how, the architecture. How do they actually build this to make the dynamic routing and selective deployment work?
Right. So high level, it's pretty neat. They use Route 53 wildcard records that directs all the PR subdomains, like prx.example.com, towards CloudFront.
Okay.
CloudFront then basically acts as the entry point. For API traffic, it forwards requests to an application load balancer, the ALB.
The ALB, that's the core piece for routing.
It's the brains, yeah. It handles the dynamic routing. It directs traffic to an ECS cluster. And in that cluster, you have both the shared default services and any new PR-specific services that got spun up.
Makes sense. And the front end.
For the front end, they used S3 and CloudFront, but in a really specific, optimized way we can get into.
Okay, so within that back end, getting that isolation without full duplication, that must have been the trickiest part.
Definitely. For the back end, their whole approach hinged on making minimal, really precise changes. They leaned heavily on application load balancer routing rules.
Right, the rules.
And PR-specific target groups within their ECS cluster. That combination was key to getting that isolated feel without copying everything.
Okay, let's unpack that orchestration. Sounds clever. So a new PR comes in. What happens?
Okay, so for every PR that needs an environment, they provision only what's absolutely essential. If you changed one microservice, they create a new temporary target group in ECS. And inside that target group, they launch just one ECS task running the container image built from your PR branch.
Just one task in its own group. Keeps resource use super low, I bet.
Incredibly low. You're basically paying for one extra container per change service, plus a little overhead for the target group. Minimal.
Okay. And the ALB, how does it know where to send traffic?
The ALB is configured to listen for those PR subdomains. When it sees a request matching, say, hostheader.pr1.example.com and path.service1, it checks its rules. If a rule exists for that specific PR and service path, it forwards the traffic directly to the corresponding PR-specific target group, PR1 Service 1 TG, for instance.
That express lane you mentioned.
Exactly, that tiny new target group with just your changed service.
And if the service isn't changed in the PR, no rule.
Correct. If there's no specific rule matching the PR and path, the ALB automatically falls back to the default rule, which points to the shared target group for that service.
So the PR environment feels complete, but it's only running the changed parts. Clever.
Very. And if you change multiple services in one PR, say Service 1 and Service 3, each one gets its own PR-specific ECS task and its own target group. And critically, they also handle downstream dependencies. Well, let's say Service 1 calls Service 2. Inside the Service 1 container running for Pro 1, the environment variable pointing to Service 2, like Service 2 host, would be set to https://pr1.example.com/service2.
Ah, so internal calls also use the PR's context. They stay within that virtual environment.
Exactly. Ensures all the traffic flows correctly, whether it's external or internal between services within the PR's scope.
That's really thorough for the back end. Okay, what about the front end? Achieving that same cost efficiency and isolation there, that can be tricky too, right? Caching, deployments.
Yeah, front ends have their own challenges. They went for a really lightweight approach here too. The core idea was using a single S3 bucket and CloudFront viewer functions.
A single bucket. For all PR front ends, how does that not get totally messy?
Structure and routing. It's quite smart.
Okay.
So that one S3 bucket holds all the front-end builds. The default build from the main branch lives in a default folder, let's say.
Okay.
Then each PR build gets deployed into its own subfolder. Pre-1, PR2, PR123, and so on.
Got it. Simple folder structure.
Yep.
Then the CloudFront viewer functions do the heavy lifting. When a request hits CloudFront, the function inspects the host header. If the host is pr1.example.com, the function rewrites the request URI before it goes to S3, changing it to ask for pr1index.html or whatever file. If the host is just example.com, it rewrites it to default index.html. So CloudFront intelligently picks the right folder based on the subdomain.
So every PR gets its own front end served from its unique subdomain, but it's all coming from one bucket managed by CloudFront rules. No new distributions, no new buckets per PR.
Exactly. Keeps it super cost effective.
And because the front end is served from https.pr1.example.com, any API calls it makes to service 1 or service 2 automatically hit the same subdomain.
Which means they naturally get routed correctly by the ALB on the back end, either to the PR-specific service or the fallback default.
Wow, that makes testing the whole thing end-to-end incredibly smooth.
It really does.
And cleanup. Just as smooth, I assume. Yep. When a PR is closed or merged, the automation kicks in. The Pre1 folder in S3 gets deleted. The CloudFront cache for that path gets invalidated. And that pr1.example.com subdomain basically stops serving that front-end content.
Tidy. A fully functional, isolated-feeling front-end, minimal cost, managed lifecycle. Very impressive. Okay, the architecture is clever, but even the best architecture can fail if it's a pain for developers to use. How did Rewa make this integrate smoothly, make it developer-friendly?
This is actually one of the most critical parts of their success, I think. They focus heavily on automation and, importantly, the developer experience. They built the provisioning workflow using AWS CDK, that's Cloud Development Kit, and step functions to orchestrate everything.
Standard, powerful AWS tools.
Right. But the crucial bit, it's all triggered directly from a Slack bot.
Ah, Slack. Okay, that's smart.
Exactly. It's fascinating how they prioritize meeting developers where they already spend their time. It removed almost all the friction.
So walk me through it. Developer opens a PR, then what? Straight to Slack.
Pretty much. Right from a Slack channel, the developer uses a command like provisionev. A little form pops up. They fill in the commit ID they want to deploy, select which service or services actually changed in their PR.
So they only build and deploy what's necessary.
Precisely. They can add optional flags too, maybe provision-specific queues or override some environment variables using JSON. They hit submit. The Slack bot then invokes the AWS step function, passing along that payload commit ID, services to provision, etc.
And the developer gets immediate feedback.
Almost instantly, Slack posts back a message saying provisioning started, and very quickly after, your environment is ready at https.pr1.example.com.
Wow, that's fast. And the step function is doing all the work behind the scenes.
Yep. It orchestrates the whole thing, extracts configs, kicks off the CI/CD pipelines, importantly, reusing build steps from their main pipeline to avoid drift, then provisions the backend services.
Which means creating the target groups, launching the ECS tasks.
Exactly. Then it updates the ALB rules to point to those new target groups, deploys the front-end build to the correct S3 folder, waits for everything to be ready, maybe runs some health checks, and signals back success.
And you mentioned it processes services in parallel.
Yeah, if you select multiple services to provision, the step function kicks off those build deploy steps concurrently where possible. That's a big reason it's so quick minutes, not hours.
The simplicity for the developer sounds amazing. So basically, just 3 Slack commands manage the whole lifecycle.
That's the beauty of it. Provision to create it, clean up AMIF to tear it down completely, and extend an IMIF if they need more time.
Extend. So they don't live forever.
Right, that's key for cost control. By default, an environment might live for, say, 60 minutes, enough for a quick review or test.
But easily extendable.
Yep. If a review takes longer, just extended MAMIV and add another hour or whatever they configure. And cleanup MAMIV is crucial. It instantly tears down all the PR-specific resources, ECS tasks, ALB rules, the S3 folder, any PR-specific queues.
Tidy again. And notifications keep everyone in the loop.
All these actions provisioning, extending, cleanup post notifications to a shared Slack channel. So the team has visibility into what environments are active.
That's really well thought out. Now, you mentioned shared resources, like the database. How do they handle data isolation practically and avoid, noisy neighbor problems where one PR's tests mess up another's?
Yeah, that's a super important point and a known trade-off of this approach. For the shared database, they rely heavily on multi-tenancy.
Multi-tenancy, so each tester uses their own account or tenant ID within that shared database.
Exactly. Test data for PR1 uses tenant A, PR2 uses tenant B. It prevents direct data collisions mostly. It's not perfect isolation, but it's pragmatic.
Okay. And for other shared things, like message queues.
For asynchronous flows, they actually do provision PR-specific SQS queues. So if Service 1 sends a message that Service 2 needs to pick up within the PR environment, it goes through a queue named something like Pro1MyQueue.
So queues get isolated. That makes sense.
Yeah, avoids messages getting mixed up between PRs or hitting the default services. And for things like feature flags, they typically connect to their shared staging environments flag service, like Launch Darkly.
Right, so you can toggle flags per user or test account.
It's about finding that balance share where you can, for cost savings, like the database, isolate where you really need to, like queues, specific service instances, and use existing mechanisms like multi-tenancy and feature flags to manage the rest.
It really does sound like they nailed the developer experience. Putting it in Slack, genius, no context switching, super fast, great visibility, turns environment provisioning into just another easy self-service task.
Totally. It lowered the barrier to using them significantly.
So, okay, we've got the architecture, the workflow.
Yeah.
What was the actual impact? What did this mean for Rewa in the real world?
Well, it wasn't just, a cool tech project. This selective deployment approach had a really tangible, positive impact, both on the bottom line, the cost, and just as importantly, on developer productivity and happiness. It fundamentally changed how they worked.
A game changer, you said earlier. Can you give us specifics? What were those key benefits they saw?
Okay, first, the obvious one, cost savings. They totally sidestepped that massive cost of duplicating everything. Instead of paying for dozens of idle services per PR, they paid for maybe one or two extra containers. Ephemeral environments went from being a luxury to something affordable for everyday use across multiple teams.
Huge. And speed.
Faster feedback loops, big time. Spin up went from potentially hours down to just a few minutes. Developers weren't drumming their fingers waiting anymore.
Right.
This meant QA could jump on things faster, product managers could review features sooner. It just accelerated the whole cycle.
And the developer experience itself.
Massive improvement. That self-service Slack workflow. Developers loved it. No more bugging DevOps, no manual deploy scripts. Every PR gets a live URL automatically. Sharing work became effortless.
Leads to more confidence too, I bet.
Absolutely. Confidence in testing. Developers in QA could finally validate changes in true isolation using that PR-specific URL. And because the internal routing was handled correctly, it drastically cut down on those, well, it worked on my machine, or it worked locally but broke in staging type problems. More confidence in merges.
And all of this must have shifted how teams work together.
Definitely. It fostered a real cultural shift. Product folks reviewing features before they even hit the main staging environment, QA teams validating multiple fixes simultaneously without stepping on each other's toes, engineers getting feedback way earlier.
So faster merges, better collaboration.
Exactly. The bottom line was lower costs, much faster iteration, and just smoother collaboration all around.
Okay, sounds fantastic. But as you always remind us, no solution is perfect. There are always trade-offs. Even Rewa's clever approach must have had some challenges or limitations, right? Ephemeral environments aren't free magic.
That's exactly right. It's crucial to understand the limitations. One of the biggest is the shared database.
We touched on that. Multi-tenancy helps, but...
But it's not full data layer isolation. You absolutely cannot safely test database schema migrations in these ephemeral environments. A migration run against the shared DB would affect everyone. Same for potentially destructive data changes. You still need other environments for that.
Okay, that's a big one to remember. Schema changes are out.
Yep. And related to that is the noisy neighbor risk, because everyone's hitting the same shared database instance.
Ah, right.
If one PR's test suite starts hammering the database with huge queries or massive data imports, it could potentially slow down database performance for other PR environments using it at the same time.
The trade-off for not duplicating the database cost.
Precisely. Another technical challenge was ALB rule scaling. ALBs have limits on how many rules you can add per listener.
So if you have hundreds of open PRs.
You could hit that limit. Their cleanup automation had to be absolutely rock solid to make sure rules associated with closed or merged PRs were removed promptly. Otherwise, you'd eventually block new environments from being created.
Okay, diligent cleanup is key. What else?
They also hit some snags with front-end caching. Serving all those PR front-ends from one S3 bucket via CloudFront sometimes led to weird caching issues, where maybe an old version of a file was served.
Tricky.
Yeah, they had to implement very targeted cache invalidations as part of the deployment and cleanup process to handle that correctly.
And the queues, you said they were PR-specific, which sounds good.
It worked well for isolation, but it added complexity. More resources to manage and clean up. And there was a risk of orphaned messages if, say, the consuming service for a PR-specific queue wasn't provisioned correctly or failed.
Right, got to make sure the whole flow works.
And finally, they are time limited by design. That default 60-minute lifespan, while great for cost, means developers do sometimes have to remember to extend Involve if a demo or review session runs long. If they forget, poof, the environment is gone.
Minor annoyance, maybe, but something to be aware of.
Exactly. These trade-offs were acceptable for Rewa given their goals and the massive benefits. But anyone considering this needs to weigh these specific limitations.
That's super helpful context.
Right.
So wrapping up this journey with Rewall, what are the big lessons learned, the key takeaways that you, our listener, can apply?
I think there are some really valuable insights here. First, and maybe most importantly, selective deployment often beats full duplication, at least for many common use cases. You probably don't need to duplicate everything to get most of the benefits. Sharing infrastructure and just overriding the changed services gives you maybe 80% of the value at a tiny fraction of the cost. Huge takeaway.
Focus on the value, not absolute perfection.
Right. Second, cleanup automation is absolutely non-negotiable. Seriously. Without robust automated cleanup of those ALB rules, S3 folders, ECS tasks, queues, you'll drown in resource leaks and escalating costs. It has to be built in from day one.
Foundational, you said. Makes sense.
Third, the database is always the hardest part. Sharing it saves a ton of money, no doubt. But it introduces those risks, noisy neighbors blocking schema migrations. Developers have to be trained and mindful about how they use the shared DB in these environments.
Culture and process around it.
Fourth, that Slack integration was key for adoption. Meeting developers in their existing workflow removed all the friction. That simple provision of command made it feel effortless, almost invisible. Don't underestimate the power of a good developer experience.
Definitely.
And finally, observability still matters, even for these short-lived environments. When a PR deployment failed, they still needed logs, metrics, traces to figure out why, just like production. So build in those observability hooks. Don't treat ephemeral infra as a black box.
Great points. What Rewa's story really shows, I think, is that ephemeral environments don't have to be this super expensive luxury. With some creative thinking, they can be practical and affordable.
Absolutely.
So to boil it down, by reusing shared infrastructure and only selectively deploying the bits that actually changed, Rewa built a system giving every PR its own live testable space without that cost explosion.
And the results followed. Developers moving faster, QA validating earlier, teams shipping code with much more confidence.
Which leaves us with a final thought for you, listening right now, inspired by Rewire's experience. Do you really need perfect full-stack isolation for every single change? Or could a selective deployment model give you most of that crucial value at a cost that actually makes sense for your team? It's a balance definitely worth thinking about for your own projects and workflows.